Welcome to Composable Cheap Canvas Story. For those who don't know me, my name is Nicole Terc. I work at Clue as an Android developer, and you can find me around with those handlers here and there. Don't ask about the dash and underscore, it's confusing for me as well. But with that out of the way, what are we going to be talking about today? As you may have imagined, we're going to be talking Canvas, but specifically we're going to start with some basics of Canvas before jumping into some compose Canvas. And of course, the most important part of this whole presentation, we're going to be talking about cheap. I hope you're ready for that. I really enjoy this cheap. But anyway, let's start with some basics. And for that, let's start with the main question. What is actually Canvas? A way to define it is that Canvas is a UI element that allows us to draw stuff in there. So it's kind of like, a real-world canvas. You just have a blank slate where you can start drawing shit. Oops. So how do we draw in this canvas? Before starting to jump into code and everything, we're going to be over a strategy that I like to follow whenever I'm going to draw something in there. And that is answering 3 questions. The first one is, what do we want to draw? The second one is, how are we going to draw it? And the third one is, where are we going to draw it? Don't worry, we'll take a deeper look on how to answer these questions. And let's begin with the what. When we talk about what, we're talking, of course, about the image we want to draw, the graphic, whatever you fancy. And of course, the answer should always be cheap. The second question, the how, this talks about how this chip is going to be drawn. Since 2 chips are not the same, this is a very important question. It refers to what color it's going to have, is it going to have a gradient, or is it going to have a specific style to it? Great, right? Well, once you already know what you want to draw and how are you going to draw it, the next important question is where you're going to draw it. If I had my real-world canvas, I just grab a pencil and I draw cheap whatever I want, but I don't think my company is going to be too happy if I start drawing in my screen. So how do we translate where we want to put it in code? We, of course, use coordinates. And when I talk coordinates, I imagine most of you had this flashback of a Cartesian plane from high school where you have these 2 axes, and whenever you had to plot something in there, you had to pass an x value and a y value. Well, Canvas works kind of similar, but not really. It's also a plane. It also has an x and a y axis, but instead of having it as a cross, it has like a weird box. It starts from 0, 0 from the top left. Yes, left. From the top left and goes all the way from the high and the width until the bottom right of the screen. All the values that we work in Canvas are positive, meaning that whenever you move to the right, it's a positive x value, and whenever you go down, it's a positive y value. So we want to plot the point 3, 3 like we have in here. We need to move 3 spaces to the right and 3 spaces down. Easy, right? I hope you all know how to plot things on this thing, and I hope it's not that confusing. A nice extra note is that we already have a nifty class that handles like coordinates inside, so you don't need to create your own coordinates class, and that's offset. So please don't create your own coordinates, just use offset. Canvas uses all around. Great. So summing up this strategy on how to draw on Canvas, we answered 3 questions: the what, cheap; the how, with groovy colors; and where, using coordinates. Great. This is a strategy we're going to follow, but of course I'm still not talking about code and stuff. So how do we do that using Compose? That's kind of the idea, right? So let's jump into that. And of course, to kick it off, we're going to take a look at our Canvas Composable. Because of course, Canvas is a composable. That's the talk. If you just come and click on it, you're going to see a definition like the one right there. You see Composable, you see Canvas, and you see only 2 parameters in there. The first one is modifier. That's a good old modifier that we always use. Something important that you may note is that this is not optional, as most of the composable functions that we have. And that's because Canvas requires a specific size to be set. So you need to pass a modifier that defines a size. It doesn't need to be like a hard-coded size. It can be like fill width or match width or whatever, but it needs to be a modifier that already has a size defined. Great. And the other parameter that we have in there is onDraw. This is the one that is going to be called whenever we're going to be drawing on the screen, and this is where the magic happens. Great, as you can see, it's a pretty straightforward composable, not that complex, right? And as you can see, most of the parameters and words in there are quite common, except for one, which is draw scope. And as I mentioned, this on draw is where the magic happens, so let's take a little better look at this draw scope. So, what is draw scope? In short, it's a thing that is going to provide you everything you need in order to draw. It creates the drawing environment, meaning the space where the canvas is going to be. It also provides the size information, so you can know where in coordinates you're going to be drawing stuff. And it also provides the drawing API. This is the API that we're going to be used to draw shapes and everything, but we'll take a deeper look at that later. So, in short, if canvas is our canvas, real world canvas space, DrawScope is kind of the one that provides you all the tools that you need in order to draw in there. So far, so good. Great. So how do we actually use this canvas composable? It's quite easy. Basically, we just create the composable, pass the modifier, remember, as I defined, and inside of this on draw lambda, we pass instructions. If I pass this instruction, of course, this is simplified, adding all the parameters or everything I want in there, you can obtain something like that. It's cute, right? But what are this drawline and drawrect? This is the drawing API that I was mentioning. And of course, in order for you to really use Canvas, you need to learn a little bit about this drawing API. So what do we have in this drawing API? In short, we have a lot of things in there. This is just a summary of the examples. I'm not going to go too deep, but basically you can use it to do three main things. To draw things like lines, points, arcs, shapes, images, and paths, to style them, passing colors, passing brushes to create gradients, passing different draw styles, like for example, this one is filled, this one is not filled, or creating different path effects like the one here. And the other thing that you can do with this drawing API is transform the things that you're creating. This means translating, which is basically moving the thing a little bit to whatever position you want, to rotate it, and to scale it. Great. I am not going to go too deep on this, but let's see an example on how to use this drawing API. And for that, let's draw a line, because lines are cool. So we're going to be drawing this simple line right there. In order to achieve that, we're only going to call our nice function called drawLine. We're going to pass the color we want. We're going to pass the start point, remember, offsets. In this case, I'm passing the 0, 0, which is the top left. And then I'm passing the end position where the line is going to end. Surprise. In this case, I'm just passing the size, width, and height. These are already provided by the drawing scope. There's nothing custom made here. Nice. I have a line. But this line is quite boring. What if I wanted to be a bit, bolder? In order to make it bolder, the only thing I need to do is pass an extra optional parameter, in this case called a stroke width. I am just passing my DPs, and a small note here, as you may notice, I'm using 2px, and that's because Canvas works with pixels. Don't worry about it. Whenever you have DPs and your designer passes you DPs, you just call this 2px, and everything is solved. Nice. But this line is too bold and too boring still, so what if I wanted to style it a bit more and make it, a dashed line? In order to do that, surprise, surprise, I just need to pass an extra optional parameter called path effect. I am just calling my dash path effect and passing intervals, and voila, you have a dashed line. All of this, as I mentioned, is out of the box. I'm still not doing anything custom here. So all of this you can achieve without creating anything at all. Nice. But what if my designer comes in and says like, hey, your line is too big, your line is too wide, your line is whatever, I want it smaller. If you want to do that, but you don't want to redo the whole thing that you already calculated, because creating a line is complex, instead of like calculating the initial position and the end position again, and then trying to calculate the width again, you can just scale it. And this is a bit different. As you notice, I am not passing any parameter this time. I'm just grabbing whatever I want to scale inside this nifty function called scale. It's the same for transform. It's the same for rotation. You just grab whatever you want to rotate, whatever you want to scale in there, and it works. There you go. And a small note, you don't need to remember of these parameters and everything. Don't worry about it. The documentation is quite nice. So if you want to see what you can do with each of these functions in Canvas, you just come and click on it, and you get all the nice parameters and things that you can pass. It is really well documented, so I highly recommend you that if you want to draw anything, just come and click on it and see what you can do. And playing around with that, you can achieve the crazy lines that I have on the left. Make sure to check the repo. Great. But enough about these lines and boring stuff. I promised you some cheap, right? So let's jump into that, and let's start playing with cheap. And in order to do that, let's go over our cheap strategy, which is basically answering our 3 questions: what, how, and where. And let's start with the what. So, what are we going to be drawing? Of course, a chip. But we don't have a draw chip function in Canvas. So in order to do that, let's try to simplify what we need to actually do with this chip. And for that, let's go over the chip autonomy. What is the components that you need in order to build a chip? Well, of course, a chip has fluff. Of course, a chip has tiny LEDs, a nice head, and really cool glasses. Great, we know what we need, right? But this chip is still a bit too complex for my tastes. Let's take a page from our artist folks, and let's try to simplify this chip a little bit. We know every chip needs its fluff, but it looks quite close to a circle. Yes, let's do a circle. And the next thing that I can see really easily that we can simplify is, cool glasses are cool and all, but I think we can live without it. Great. We have a basic chip. And this basic chip looks really, really easy to do, right? If we just observe the components that we need, we can see that we need a circle for the fluff, we need tiny legs for the rects, and just an oval for the head. Great. We have the answer for what? But we haven't seen how to draw any of these components yet. So how do we do that? In order to draw a circle, we have our draw circle function like the one there, where we pass color, radius, center, and style. And that's basically it. I hope everybody here knows what a radius and the center is, but basically the radius is the radius of the circle, and the center is where you want to position this circle. The style and passing field, because we're not going to be drawing a stroke chip, we're going to be drawing field chip. Great. What was the other component that we needed to do? Oh yeah, rects. In order to draw rects, we call draw rects, which is basically, again, passing a color that we need, passing the size of the shape we want, passing the top left, and this is something important. Most of the canvas elements that we're going to be drawing uses the top left as a base coordinate to draw stuff. It just means the top left corner. And of course, it's an offset. And the style. Great. But we're missing still the oval. In order to draw an oval, you just call draw oval. And as you can see, the parameters are basically the same as the rect. That's because basically how it works behind is that we use this rect, and our Canvas API is going to be drawing the oval that fits in there. Great. We know what we need to draw. We need how to draw each of these elements. So that's it for our basic chip, right? We have the what. Now, how are we going to be drawing this basic chip? In this case, we're going to keep it simple again because we don't want to overload things here, so we're just going to use colors. In this case, let's use a light gray for the fluff, and dark gray for the legs, and the head. That's it. Great. That was easy, right? So far, so good. We have the what, we have the how. Let's go to the where. And that, of course, means where in this set of coordinates are we going to position our chip? We have 3 elements in here, so I cannot just only pass one set of coordinates. I need to define where the fluff, where the head, and where the legs are going to be. And for that, of course, we need to use some maths. Let's go over the chip maths now. We're going to be drawing fluff, head, and legs, so let's go over each of them. First, the fluff. We know that the fluff is a circle. And in order to draw a circle, as we saw, we need 2 things. We need the center, and we need the radius. How are we going to be calculating these things? We're just going to do as follows. For the center, I'm keeping it simple. I'm just going to use the center of the canvas, so there's nothing I need to do there. I already have it. And for the radius, I like 1/3. Why not? This is me defining things, so you can basically just play around and define it as you want. Great, we have the fluff. Now, let's go for the head. The head, as we know, is an oval. And in order to draw an oval, we need a size, and we need the top left corner. So how are we going to be doing that? We're going to be doing that. Don't worry about the numbers. It was just basically me playing around with how this looked like and how it looked better or not. So basically, you can define and play and match with it. For the size, I'm basically using a 2/3 radius oval, and I'm just moving it a little bit up and a little bit to the left. Great. We had the head. Now the legs. The tiny legs, of course, are going to be 2 rects, and in order to draw rects, we need a size, and we need the top left. The strategy that I follow here was basically, instead of like creating the little squares that I needed on the bottom and get complicated calculating where these were going to be, I just created some kick-ass large rectangles in there. I'm already using like the center of the canvas for that, so that's what I use. And this is, again, me playing with this. Don't take this as science for real. But anyway, about this boring talk, let's go over it, and let's just, let's see some code. Great. Here we have our basic chip. As you can see, I am just passing my colors as we defined. I am creating my canvas. I hope everybody can see it right. Yep. We're passing the canvas, remember, specific size. And in here, I am just doing the calculation that I wanted. 1/3 of this, then the legs. And this is something important. As you may notice, I'm starting with the legs. And that's because in Canvas, whenever you're drawing stuff, whatever you draw first is going to be the one below the next drawing. So of course, I don't want my legs on top of all the chip, so I start with that. We create the legs, we just get calculations, we draw the rects for each of them, we draw a circle for our fluff, and then we draw our head. And let's ignore the show guidelines, that's just an extra thing that you can try around. And by doing that, what is that chip? It plays around with the preview thing, but let's minimize this thing. There you go. We got a basic chip. There you go. We didn't do much, and we already have a chip. But this chip is a bit too basic, don't you think? I am not quite satisfied with that because, a chip is nothing with its fluff, so let's give it a go and try to make a fluff, shall we? So let's go over our maths again, and let's try our fluff 2.0. Nice. And for that, let's grab our original chip, let's put it behind, and let's try to think a bit, how are we going to be doing these fluff things? A simple way that I can think of is, if I use my imagination, I can picture each of these things as a tiny circle just popping out of the body, right? And I can define that each of these little fluffs in there are all of them tiny circles. It could work, right? It sounds like it could work. And in order to draw circles, we already know that we need center and radius. How are we going to obtain those? Well, if we take a look at how this center and radius, ignore that it's not centered, at work, the center is not really touching my circumference, but we have 2 points that do. And those right there are going to be the key in order to find the center and radius for each of our fluff. And I'm going to go ahead and call these little points where my circumference touches these little circles fluff points, because why not? So the strategy is going to get each of these points, and then using those points, I'm going to get my center and my radius. Don't worry, it's going to be easy. So how are we going to do that? What do we know about fluff points? As I mentioned, the fluff points are going to be the intersection of the fluff circles and the body circle. All of these little red points in there. What do we know? We know that these points are touching the circumference of the body. Yes, I am talking heavy words now. We know that the distance from the center to these points is constant because we know the radius, right? Circle radius, yes. And what other things, what can we know about this? We know the angles. Believe me, we do. Basically, we're going to do this like, equal size and equal distance so we can obtain those angles. So how are we going to do that? What do we need? We're talking circles, we're talking angles, we're talking radius and shit. How do we do that? With trigonometry, of course. And when I talk trigonometry, don't be afraid. Of course, I talk about these 3 good fellas, sine, cosine, and tangent. We're going to be using this in order to obtain our points. So how are we going to be doing that? Well, we grab our chip, our strategy of getting the angles and getting the things, we add some trigonometry magic in there, and then we obtain the answer of everything. Just kidding, we get the fluff points. I'm not going to go deep on the maths, don't worry about it, but if you're curious, you can just check the repo and see what I did. It's not that complex, but it's not important. Great, so we got the fluff points. What are we going to be doing with those? We're just going to use another magical feature, which is geometry. And when I talk geometry, of course, I talk about these nice formulas in there of getting distance between points and middle points. And using those, I am going to get the center and the radius. It works. It works. Once we got those, we're going to be able to build, finally, our fluff. But let's see it in code, shall we? Nice. So I, of course, went ahead and already have my nice function in here, which is nice. You can extend it, by the way. That's a nice key. And in here, I'm just getting my full circle. I'm dividing it, and I'm doing the magical maths for us, and then drawing circles for each of those. Don't worry about it. You can take a closer look later. But how are we going to be adding that here? We just need to go after our fluff. Remember, the thing that we draw first is below. And in here, we just need to call our fluff circle symbol there. We just pass it, and drum roll, please. Ta-tan! We have a fluffy chip. This still doesn't look quite good, don't we? One of the solutions that we can do is we can pass more circles, or not, if my Android Studio gets angry. But basically, we pass more. We can try to, make the circles less big, smaller, and in that, we can obtain a more fluffy-ish shape. But I'm still not happy with this fluff. I'm sorry. Do you want to give it another try? Let's try it. Let's try it. Let's go over fluff 3.0, this time for real. So how are we going to be doing that? If we go back to our circles, we can see where our original fluff 2.0 went wrong. And that's our circles are too circular. We need a, kind of a curve that is a bit flatter. But how are we going to be doing that? How we can, draw an arc that is not circular, because circles are not that cool? Don't worry, I did my homework. I have the answer that I use, and that, of course, is using Bezier curves. Yes, of course, that's the answer. But we didn't saw any function that had Bezier curves in that drawing API that we saw, right? And that's because it's not inside the drawing API. It's actually inside pad. But we haven't also take a look at pad, so let's take a look at pad and take a small detour before going back to our fluff 3.0, and let's talk about pad. So if we take a look at our function for pad, we see something like this. You can see that most of the parameters in there are quite straightforward. We have colors, we have alphas, we have styles, we have those already in the line, so it's okay. The only thing that pops up, of course, is pad. Great, but what is this pad? What does it actually do? A way to define it is that pad is a collection of lines and curves that can be used to draw in a canvas. Nice, right? Another way to see it is that it's basically just a set of instructions. Yeah? No? Not yet? OK. Another way that I like to see pad is, remember those dot-to-dot drawings that you used to do when you were a kid, where you had number 1 to 2 to 3 to whatever? That's how pad works. It doesn't have any information about colors. It doesn't have any information on how the line is going to be. It just tells Canvas where to go from the point it is, and what is the next point, what is the next point, yada, 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 yada. The only information that it has is if it's a line or if it is a curve. Great. We have pad. But how do we create this pad, right? Well, that's pretty easy. You just create it. There you go, a pad. But an empty pad is not going to do you any good, right? Of course, we need to pass a set of instructions. And for that, you can call pad and start adding things, but we're in Kotlin, so I'm just going to go lazy and go apply. And inside that apply is where all the instructions of the pad are going to be. In this case, I am just calling move to, which is just going to move your pointer where you go, and then just creating some lines. And if you run these things, don't worry about this. This is just an example. You don't get anything, because that pad, as I said, doesn't have the information of anything. So in order to this pad to show in your screen, you need to actually call drawPad. So we call drawPad, we pass the pad, and in here is where the information of the color and the style and everything goes in, and ta-da, you get a pad. In this case, I am just creating 3 lines. Easy, right? I hope this clarifies a bit how pad works and you're not so afraid to play with it anymore. But we were talking about something called Bezier curves, whatever. How do we actually do that? Well, believe it or not, going back to our pad, the only thing you need to do is pass the instruction for the quadratic Bezier curve. Of course! But it's kind of confusing, right? It has that x1, j1, x2, j2. What are we talking coordinates here? Let's take a deeper look on how quadratic Bezier curves actually work in order to understand what the hell I'm doing here. But it works. Look, there's a curve. So how does this work? In short, quadratic Bezier curves are a curve creating between 2 points using a control point to shape it. So if I have like this, for example, 3 examples of curves where the start and end points are the same, depending on where I put this control point is how this is going to change. Don't worry too much about the details. I'm not going to go deeper than this. But if you're curious about how Bezier curves work, I highly recommend this video by Freya Holmer. It's really, really nice. But the only thing you need to remember is Bezier curves, you have 2 points, the initial point, the end point, and a control point that you're going to use to draw it. Great. So going back to our example there, where we have our curve, you can see that the first point that I'm passing is the control point. And the second one is the end point. You may be wondering what the start one is, but remember that pad is like the dot-to-dot thing. So the start point is whatever the pad currently is. Great. We have our Bezier curves and our pads, so we can go back to what we were trying to do originally, which was create our fluff. So we already said we're going to use Bezier curves. And in order to create this, we need the start and end points, and we need control points. So how are we going to be doing that? If we observe closer, we can see that our start and end points, we already talked about those, right? Those were our fluff points. So we have them. Great. Now, how are we going to be calculating our control points? Remember that the control points are the little point in red in there. And since I don't want to complicate my fluff because this is already getting too out of hand, I'm just going to use the basic one right there, where the distance for the control point is the same for each of them. So how are we going to be doing that? I am going to use the same circumference that we have in there. And I'm going to plot it in there. The main idea is that I'm going to graph, and I'm going to get a bit technical here. I'm going to have my diameter formed by the fluff points, and I'm going to obtain the point that it's perpendicular to it in order to use it as a control point and create my curve. I'm going to go deeper than that, but we use geometry for that again, and boom, you get the control points. Again, for the curious, make sure to take a look at the code base in order to take a look at how I did it. But let's see some code of this actually working. And for that, I'm going to jump into my draw fluff. Here, this is actually a code I'm already using for my Composable chip, is where I obtain the fluff pad for my chip. As you can see, I'm just creating a pad, I am passing the apply, I am setting the initial point, and then I'm just creating for each of the fluff points that I have, get a control point, and draw a quadratic Bezier. And that's it. I'm just creating quadratic Bezier of each of these points, and using that, I get a nice fluff. And of course, you can play around and change the stuff in here, which is something you can do if this clicks in my nice, nifty, already screen that you can play around. You can play in the style, and you can change the stuff, and be sure to take a look on how this works. Great! We have finally a fluffy chip. It wasn't that hard, right? We just create a pad, we learn about some curves and stuff. But if you don't like it, you can always go back to the basic chip and just, create the flowery thing if you want. Nice. So, some final notes about this. Why do you actually care about all the things that I was mentioning? Why do you care about Canvas? Why do you care about all this chip and weird curves and everything? Of course, the first thing is to create some nice and fun UI. And chip. Chip are important. And the second part is for animations. Using Canvas in pair with animations, you can create really, really crazy stuff. But that is a topic for another talk. So thank you. Yay. If you want to learn more, as I keep saying throughout the whole slides, you can take a look at the repo. You can take a look at the documentation. The documentation is quite nice. And as I recommend the video from Freya Homer, it's really cool. If you want to learn a bit more about the maths I use, these are the reference of the images, but you can just Google them. But that's all. Any questions? Great. I think that's it then. See you around. Thank you.